Chapter 1, Introduction to Operational Management. 8 topics. 5 questions. 1. What is digital operations management? What are the common areas of application? Digital operations management, DOM, refers to the integration of digital technologies into operational processes to enhance efficiency, productivity, and customer satisfaction. It includes the management of resources, processes, and technology to deliver products or services effectively. It transforms traditional operations into automated, data-driven, and intelligent workflows, enabling businesses to work more efficiently, reduce costs, and adapt quickly to change. Example: a manufacturing company uses IoT sensors to monitor equipment in real time, improving maintenance, reducing downtime, and increasing efficiency. 2. 5 common areas of application for DOM IT operations: customer service, supply chain and logistics, finance and HR, manufacturing. 3. 6 steps in digital transformation: define clear objectives, assess current state, develop a digital strategy, invest in technology, implement in phases, monitor and adapt. 4. 5 strategy of change management: communicate the vision, involve stakeholders early, provide training, encourage feedback. Reward and recognize. 5. Digital tools and technologies. Digital tools and technologies are essential for the success of digital operations, as they help organizations improve efficiency, streamline processes, and make better decisions. These tools can range from simple applications like email and spreadsheets to advanced systems such as customer relationship management, CRM, and enterprise resource planning, ERP, platforms. Some common digital tools and technologies used in digital operations include: 1. Cloud computing allows businesses to store and access data and applications over the internet instead of relying on local servers or computers. Example: a company uses Google Drive to store and share files online. 2. Artificial intelligence, AI, automates routine tasks, analyzes data, and supports smarter decision-making. Example: a chatbot automatically replies to customer questions. 3. Internet of Things, IoT. Devices like sensors and smart devices collect and transmit data in real time, enabling better monitoring and control. Example: sensors in a factory track machine performance in real time. 5. Value-added services. Value-added services, VAS, in digital operations management refer to additional services that enhance a company's core offerings, creating more value for customers. VAS can help differentiate a business in a competitive market, improve customer satisfaction, and foster customer loyalty. By integrating VAS into digital operations, organizations can optimize processes and deliver enhanced experiences. Examples of VAS include: 1. Personalized recommendations. E-commerce platforms like Amazon suggest products based on customers' past purchases, improving the shopping experience. 2. Real-time customer support. Companies such as Zappos provide 24/7 chat support to ensure immediate assistance for customer inquiries. 3. Data analytics services. Tools like Google Analytics offer insights into user behavior, allowing businesses to optimize their digital marketing strategies. 4. Loyalty programs. Starbucks uses its app to reward customers with points for purchases, increasing customer retention and engagement. In conclusion, value-added services allow businesses to go beyond basic offerings, creating more personalized, efficient, and satisfying experiences for customers while supporting operational excellence and competitive advantage. Chapter 2, System Implementation Requirement. 1. System implementation requirement. System implementation refers to the process of installing and operating a new system according to specific specifications and conditions. It involves meeting both technical and non-technical requirements to ensure successful deployment and functionality. 1. Hardware requirements include all physical devices necessary for the system, such as servers, storage devices, and workstations. For example, a company upgrading to a new database system might require high-capacity servers to handle increased data processing. 2. Software requirements consist of operating systems, applications, databases, and licenses needed for the system to function. For instance, implementing an ERP, Enterprise resource planning. System like SAP or Oracle allows businesses to manage operations efficiently. 3. Network requirements cover the connectivity, bandwidth, security protocols, and infrastructure needed to support the system. An example is setting up a virtual private network, VPN, to secure remote access for employees while maintaining reliable data transmission. In conclusion, successful system implementation depends on carefully addressing hardware, software, and network requirements to ensure that the system operates efficiently, securely, and meets the organization's objectives. 2. System requirements for a payroll system. Functional requirements. Employee data management, payroll calculation, tax and compliance management. Non-functional requirements. Performance, security, usability. Technical requirements. Hardware, software, network. 3. Implementation plan and strategy. 1. Project timeline. Phase 1, requirement gatherings and requirements. Phase 2, system development and integration. Phase 3, testing and evaluation. Phase 4, deployment and training. 2. Resource allocation. 3. Testing. Phase 4. Training and user onboarding. 5. Post-implementation support. Chapter 3, Service Configuration Management. 1. General explanation of Service Configuration Management, SCM. Service Configuration Management, SCM, is the process of identifying, recording, and managing all configuration items, CIs, and their relationships to ensure accurate and reliable IT services. The main objective of SCM is to keep accurate information about IT assets so that changes or issues can be managed effectively, reducing risks and improving system stability. 2. 4 main component processes of SCM configuration management ensures that all IT components in healthcare are tracked, maintained, and documented to support reliable operations, reduce errors, and improve patient care. It involves identifying, monitoring, and auditing hardware, software, and documents to maintain an accurate record of all configuration items, CIs. 1. Identification. The IT team identifies all hardware, software, and documents essential to operations, ensuring each CI has a unique identifier and is listed in the CMDB. 4. Example, MRI machines, EHR software, and operational manuals are cataloged in the CMDB for proper tracking and management. 2. Change management. When a software update is required for the EHR system, a change request is submitted, assessed for potential impacts on other CIs, and approved before implementation. For example, updating imaging software is carefully reviewed to avoid conflicts with CT scanners or network servers. 3. Status reporting. Regular updates are provided for critical CIs to detect and resolve issues quickly. For instance, the status of MRI machine software is monitored daily to ensure it remains operational, and any downtime is reported immediately to minimize disruptions in patient care. 4. Verification and audit. Periodic audits are conducted to confirm that all CIs in the CMDB are accurately documented and reflect the current state. For example, backup servers are checked to ensure they are correctly configured and ready to operate if the primary servers fail. Effective configuration management ensures that IT systems in healthcare remain accurate, reliable, and efficient. By following these processes, hospitals can reduce operational risks, maintain high-quality services, and provide consistent support for patient care. 3. Benefits of SCM. Different Service Configuration Management, SCM, is the process of identifying, recording, and managing all configuration items, CIs, and their relationships to ensure accurate and reliable IT services. By systematically tracking hardware, software, and processes, SCM helps IT teams prevent errors, reduce risks, and maintain compliance with industry standards. 1. Enhanced service quality. SCM ensures that all hardware, software, and processes are up to date and functioning properly. For example, a tech company uses CMDB records to quickly identify and fix software issues, improving service quality. 2. Reduced downtime. IT teams can quickly identify and resolve issues, minimizing system interruptions and keeping services available. For instance, a bank uses SCM to track systems, and quickly replace failing servers with backups, minimizing downtime for online banking services. 3. Improved change management. SCM helps IT teams plan and monitor changes carefully, reducing errors or conflicts during system updates or modifications. For example, an e-commerce site uses SCM to assess system impacts before updating its payment system. 4. Compliance with standards. SCM helps organizations track systems and configurations to comply with regulations. For example, a bank keeps records of software updates to prove compliance during audits, ensuring compliance rules for data handling. 5. Better risk management. By maintaining detailed information on CIs and their relationships, SCM enables teams to prevent risks. For example, an insurance company uses SCM to identify affected systems and apply patches, preventing bigger operational issues. In summary, SCM provides multiple advantages, including improved service quality, reduced downtime, better change management, regulatory compliance, and risk mitigation. These benefits ensure that IT systems remain reliable, efficient, and capable of supporting organizational goals. 4. 6. Service SCM ServiceNow, Ansible, Puppet, Chef, Microsoft System Center Configuration Manager. 5. Challenges in service configuration management. Implementing service configuration management, SCM, can significantly improve IT operations, but organizations may face several challenges during adoption. These challenges often involve complexity, data accuracy, staff adaptation, and system integration. 1. Complexity of managing multiple CIs. Handling numerous configuration items, CIs, can be complicated as it requires tracking all components and ensuring proper maintenance. For example, a company with multiple departments find difficulty in managing updates and maintenance schedules as the number of devices increases. 2. Data accuracy issues. Ensuring the correct information for each CI can be challenging and may lead to errors in decision-making. For instance, incorrect customer phone numbers in a database cause communication problems when contacting customers. Chapter 4. Incident Management. 1. 5 Importance in digital operations. Incident management is the process of identifying, analyzing, and responding to incidents in order to minimize their impact on business operations. The main objective is to restore normal service operations as quickly as possible while ensuring minimal disruption to users and organizational activities. 1. Minimizes downtime. Incident management ensures that system failures are detected and respond quickly to technical issues, so that organizations can restore operations faster and maintain business continuity. Example: in a bank, a system outage stops ATM transactions, and the IT team quickly fixes the issue to restore services. 2. Improves service reliability. Incident management strengthens system stability by ensuring that issues are properly diagnosed and resolved, preventing repeated failures. Example: an IT team's swift response to a system outage not only restores service, but strengthens long-term reliability for all customers. 3. Enhances customer satisfaction. Fast incident response and clear communication improve user experience and trust in digital services. Example: when a streaming app crashes, the incident management team promptly resolves the issue to minimize frustration and maintain customer loyalty. 4. Reduces financial loss. Incident management helps organizations avoid revenue loss by minimizing service disruptions and operational downtime. Example: when a payment gateway fails, incident management quickly resolves it to prevent financial loss and maintain customer confidence. 5. Supports continuous improvement. Incident management encourages learning from system failures through reviews and analysis. Example: a digital marketing platform experiences repeated login failures, and a post-incident review identifies the cause and implements improvements to prevent recurrence. By addressing incidents quickly and systematically, incident management plays a vital role in digital operations by ensuring system stability, minimizing disruptions, improving service quality, protecting revenue, and supporting continuous organizational improvement. 2. Incident management process. The incident management process is a structured approach used to identify, manage, and resolve incidents in order to minimize their impact on business operations. It focuses on restoring normal service as quickly as possible, ensuring minimal disruption to users and services. 1. Identification. Identification is the process of detecting and recognizing that an incident has occurred. In a hospital appointment system, the receptionist notices that the system is not loading patient booking records, which signals that an incident has occurred too. Categorization. Categorization involves classifying the incident based on its nature so that it can be handled by the appropriate technical team. For example, the system cannot display patient appointment details, and the issue is categorized as a system access failure. 3. Prioritization. Prioritization determines the urgency and business impact of the incident in order to decide response speed. The IT team assigns high priority because the issue disrupts patient appointments and hospital operations. 4. Response. Response involves taking immediate action and communicating with affected users while the issue is being addressed. The receptionist informs patients about the system issue and delays, while the IT team starts troubleshooting. 5. Resolution. Resolution is the process of fixing the incident and restoring the system to normal functioning. The IT team repairs the system error and restores access to the appointment database so bookings can continue. 6. Closure. Closure involves confirming that the incident has been fully resolved, documenting the case, and conducting a review to prevent similar problems in the future. After restoration, the incident is closed and the hospital reviews system performance to improve reliability. Overall, the incident management process ensures quick identification, proper handling, and effective resolution of incidents, helping organizations maintain smooth operations and minimize disruptions. Chapter 5. IT Operations Automation through Machine Learning. 1. Machine Learning in Digital Operations Management. Machine learning in digital operations management uses data-driven algorithms to learn from historical and real-time data, improving decision-making, automating workflows, and enhancing operational efficiency without explicit programming. It helps organizations analyze data, identify patterns, predict future outcomes, and reduce operational costs. 1. Demand forecasting. Machine learning predicts customer demand from past data and behavior, reducing stockouts and overstocking. Example: Amazon forecasts demand and uses anticipatory shipping to move products closer to customers, minimizing delays. 2. Inventory optimization. It automatically adjusts stock levels using predictive insights. Example: Walmart analyzes sales data to replenish stock and prepare for demand spikes, such as before hurricanes. 3. Supply chain optimization. Machine learning adjusts production and distribution based on real-time sales and preferences. Example: Zara monitors daily sales and customer trends to quickly update production, reducing waste and keeping popular items in stock. Overall, machine learning enhances forecasting accuracy, optimizes inventory, improves supply chain responsiveness, automates decision-making, and helps organizations increase efficiency, cut costs, and stay competitive. 3. Challenges of implementing ML. Implementing machine learning. ML offers many advantages, but organizations may face several challenges during adoption. These challenges relate to cost, data quality, and ethical concerns, which must be managed carefully for successful implementation. 1. Data quality and large data requirements. ML models need large volumes of accurate and reliable data to perform effectively. Poor quality or incomplete data can lead to inaccurate results. For example, a hospital using ML for disease diagnosis must ensure medical data is clean and well labeled. Inaccurate data may lead to incorrect diagnoses. Chapter 6. IT Operations Analytics, ITOA. IT Operations Analytics, ITOA, is the practice of collecting and analyzing IT system data to enhance decision-making, efficiency, and overall performance. It uses big data, AI, and machine learning to identify patterns, predict issues, and automate responses in complex IT environments. 1. Key components of AI Ops. AI Ops. consists of several key components that work together to enhance IT operations through automation and intelligent analysis. These components enable organizations to monitor complex systems, detect issues early, and respond efficiently. 1. Big Data Platform. AI Ops relies on a big data platform to collect, store, and manage large volumes of diverse IT data from sources such as servers, applications, networks, and cloud systems. For example, a company collects data from all its systems into one platform to monitor performance easily. 2. Machine learning algorithms. Machine learning models analyze the collected data to detect patterns, identify anomalies, and predict potential failures or performance issues. For example, the system detects unusual activity and predicts a server failure before it happens. 3. Real-time analytics. Real-time analytics process incoming data instantly, allowing organizations to detect issues as they occur. For example, the system immediately alerts the IT team when a server slows down. 4. Visualization dashboards. AI ops platforms provide dashboards that display system metrics, alerts, and performance indicators in a clear and user-friendly format. For example, IT staff use a dashboard to check system status and identify problems quickly. 5. Automation tools. AI ops integrates with IT service management, ITSM systems to automate routine tasks such as restarting services, allocating resources, or generating incident tickets. This reduces manual workload and improves operational efficiency. For example, the system automatically restarts a failed service without human action. 2. The ITOA process. How leading companies manage IT operations. 1. Data collection. The first step involves gathering logs, metrics, and event data from various systems, networks, and applications. For example, Google collects user activity logs, error logs, and system performance metrics from Gmail servers. 2. Data aggregation. After collection, the data is centralized into a single platform and standardized for consistent analysis. For example, AirAsia centralizes data from booking systems, payment gateways, and check-in systems into one dashboard for real-time monitoring. 3. Analysis and correlation. AI algorithms analyze the aggregated data to identify problems and detect anomalies to determine root causes. For example, Netflix analyzes viewing patterns, server errors, and user complaints to determine whether a streaming issue is caused by server overload. 4. Visualization. The analyzed results are displayed through dashboards, graphs, or real-time alerts to provide clear insights for IT teams. For example, Amazon Web Services, AWS, provides real-time dashboards that show CPU usage, memory load, and application errors to help developers monitor system performance. 5. Actionable insights. Finally, the system generates recommendations or automatically performs corrective actions to resolve issues and optimize performance. For example, Meta Facebook uses AI-driven recommendations to automatically shift data traffic or scale servers when user activity increases. Overall, the ITOA process enables organizations to move from reactive IT management to proactive and data-driven operations, ensuring system stability, performance optimization, and business continuity. 3. List of ITOA tools. 1. Splunk 2. AppDynamics 3. Dynatrace 4. Datadog 5. SolarWinds 10. The impact of AI on IT operations efficiency. Artificial intelligence. AI has significantly transformed the IT industry by improving efficiency, reshaping job roles, and creating new opportunities. The impact of AI on IT operations greatly improves efficiency through automation, prediction, and data management. 1. Automated problem detection and resolution. AI continuously monitors IT systems and identifies anomalies in real time. For example, if the platform detects an unusual spike in network traffic, AI detects high network traffic and redirects it to another server. This reduces downtime and ensures uninterrupted service. 2. Predictive analytics. AI analyzes historical data to forecast potential issues before they occur. This helps IT teams prepare in advance and avoid system failures. For example, AI predicts high server load and increases system capacity. 3. AI-driven data management and reporting. AI platforms generate automated reports on server health, network performance, and system trends. For example, IT teams receive system performance reports for areas of improvement without manual analysis. This saves time and supports data-driven decision-making. 4. Enhanced speed and accuracy in operations. AI processes large amounts of data quickly and accurately compared to humans. This improves system performance and reduces errors. For example, AI analyzes system logs instantly to detect unusual patterns. 5. Reduction in manual workload. AI handles repetitive tasks, allowing IT staff to focus on more important activities like planning, decision-making, and innovation. For example, IT managers use AI insights to improve system design instead of doing routine checks. Overall, AI is reshaping the IT industry by automating routine tasks, increasing operational speed and accuracy, reducing manual workload, and creating new career opportunities. While some traditional roles may evolve, AI ultimately enhances productivity and enables IT professionals to focus on higher value and strategic activities, driving innovation within organizations. Chapter 9: Data Analytics in IT Operations, ITOA 1. 5 Key Applications of Data Analytics in IT Operations. 5 marks. Data Analytics in IT Operations. Data analytics in IT operations involves analyzing data generated from IT systems such as servers, applications, and networks to improve system performance, reduce outages, and detect problems early. 5 key applications of data analytics in IT operations are as follows. 1. Performance monitoring. Data analytics helps organizations monitor the performance of servers, networks, and applications by analyzing system logs and performance metrics. Example: Netflix uses data analytics to monitor the speed and uptime of its streaming. Services globally. If a server slows down in one region, analytics alerts engineers before users notice. 2. Predictive maintenance. Predictive maintenance uses historical and real-time data to anticipate potential hardware or software failures before they occur. Example: Dell uses predictive analytics in its data centers to detect early signs of hardware failure and replace components before breakdowns happen. 3. Incident management. Analytics tools automatically detect unusual system behavior and generate alerts, helping IT teams respond quickly to technical problems. Example: PayPal uses analytics to identify spikes in failed transactions and immediately alert IT teams so they can resolve issues in real time. 4. Capacity planning. Data analytics analyzes system usage trends to help organizations plan future infrastructure needs and ensure systems can handle high workloads. Example: AWS studies historical usage data to ensure enough server capacity is available to handle traffic spikes during major events such as Prime Day. 5. Security analytics. Security analytics analyzes system logs and user activities to detect suspicious behavior or unauthorized access attempts. Example: IBM uses analytics tools to monitor unusual login activities and detect potential cyberattacks on internal systems. 4. 5 popular tools for IT operations analytics. 1. Splunk 2. Datadog 3. New Relic 4. Elastic Stack 5. Prometheus and Grafana 1. 5 types of data collected. IT Operations Analytics, ITOA, collects and analyzes data from IT systems to monitor performance, detect issues, and support efficient decision-making. It enables organizations to identify problems early, improve system reliability, and maintain smooth digital operations. 1. Server logs. These record activities and errors occurring on servers, helping IT teams identify system issues and failures quickly. Example: server crash logs during peak usage help teams detect overload problems and restore services. 2. Network traffic data. This shows how data flows between systems and helps detect unusual patterns or disruptions in network activity. Example: a sudden spike in traffic may indicate a cyberattack such as a DDoS attempt. 3. Application performance data. This measures how well applications function, including speed, responsiveness, and resource usage. Example, an app running slowly due to high CPU usage can be identified and optimized. 4. User behavior data. This tracks how users interact with systems, helping improve user experience and identify usability issues. Example, users abandoning an online form halfway may indicate design or performance problems. 5. Security event logs. These capture security-related activities and potential threats, supporting risk detection and prevention. Example, multiple failed login attempts from the same IP address may signal unauthorized access attempts. In conclusion, ITOA uses various types of data such as server logs, network traffic, application performance, user behavior, and security logs to enhance system monitoring, improve performance, detect threats early, and ensure reliable and secure IT operations. 2. 6 key metrics in IT analytics monitoring system performance is essential for ensuring reliability, efficiency, and a smooth user experience. Organizations track several key metrics to maintain optimal operations and quickly respond to issues. 1. System uptime measures how long a system remains operational without interruption, indicating overall reliability. Example, a server maintaining 99.9% uptime over a month reflects strong system stability. 2. CPU and memory usage tracks how system resources are utilized to identify potential overloads or inefficiencies. Example, CPU usage reaching 95% during processing may indicate a performance bottleneck. 3. Response time indicates how quickly a system or application responds to user requests, affecting user experience. Example, a web page taking 3 seconds to load instead of 1 second may reduce user satisfaction. 4. Error rate measures the frequency of system or user errors to identify recurring issues. Example, 10 login failures per hour may signal system errors or security concerns. 5. Mean time to detect, MTTD, calculates the average time taken to identify a system issue after it occurs. Example, detecting a database crash within 10 minutes shows efficient monitoring. 6. Mean time to resolve, MTTR, measures the average time required to fix an issue and restore normal operations. Example, resolving a network outage within 30 minutes indicates effective incident response. By monitoring these metrics, organizations can detect problems early, improve performance, and minimize downtime, ultimately ensuring smoother operations and better user experiences. 3. 5 challenges of data analytics in IT, 5 marks. 1. Large data volume. 2. Real-time processing needs. 3. Data from many sources. 4. Skill gaps. 5. Data privacy concerns. Chapter 10, Cloud Technology and Virtualization. 6 questions. Tutorial 1. What is cloud computing? 2 marks. Cloud computing is the delivery of computing services over the internet, also known as the cloud. It provides on-demand access to resources such as servers, storage, and software without direct user management. 2. Discuss 3 types of cloud computing with examples. 9 marks. 1. Public cloud. Customers use processing, storage, networking, and other computing resources from third-party providers called cloud service providers, CSPs, to run their information systems. Example, Amazon Web Services allows businesses to rent computing power and storage on a pay-as-you-go basis. 2. Private cloud. Provides computing, storage, and software services dedicated to a single organization and can be managed internally or by a provider. Example, Microsoft Teams uses a private cloud for secure internal communication within an organization. 3. Hybrid cloud. Combines both public and private cloud services, allowing data and applications to work across both environments. Example, Netflix uses a hybrid cloud approach to manage streaming services and data efficiently. In conclusion, public, private, and hybrid clouds offer different levels of accessibility, control, and flexibility. Organizations choose the most suitable type based on their needs, cost considerations, and data security requirements. 4. Discuss 3 types of cloud service models with examples. 9 marks. Cloud computing is a model of computing where processing, storage, software, and other services are delivered over the internet instead of relying on local servers or computers. 3 types of cloud computing services are as follows. 1. Infrastructure as a Service, IaaS. Customers use processing, storage, networking, and other computing resources from third-party providers called cloud service providers, CSPs, to run their information systems. Example, businesses use Amazon Web Services, AWS, to rent infrastructure such as storage and servers instead of owning physical hardware. 2. Platform as a Service, PaaS. Customers use infrastructure and programming tools supported by the CSP to develop, test, and deploy their own applications. Example, IBM Cloud provides development tools that allow businesses to build applications without managing the underlying hardware. 3. Software as a Service, SaaS. Customers use software hosted by the vendor on the cloud infrastructure on a subscription basis. Users access applications through a web browser without installation. Example, Salesforce offers customer relationship management, CRM, software that can be accessed from anywhere online. These cloud computing service models provide businesses with scalable, flexible, and cost-efficient solutions for infrastructure, application development, and software usage in modern digital environments. 4. How does data security differ in cloud systems compared to traditional infrastructure? 20 marks. Data security protects data from unauthorized access, theft, or damage. It differs between traditional infrastructure and cloud systems due to control, management, and security approaches. 1. Control over data. Traditional systems provide full internal control over servers and security, while cloud systems share control with providers. Example, a company secures in-house servers, while AWS manages infrastructure but users control access settings. 2. Access management. Traditional systems limit access through internal authentication, whereas cloud systems use role-based access for flexible and remote control. Example, employees access internal servers locally, while Azure allows only HR to access specific data. 3. Data encryption. Traditional infrastructure manages encryption internally, while cloud providers offer built-in encryption with optional user-managed keys. Example, a company uses VPN and disk encryption, while Google Cloud encrypts stored data automatically. 4. Monitoring and threat detection. Traditional systems rely on in-house monitoring, while cloud systems provide automated and AI-driven detection. Example, manual log checks versus AWS CloudTrail automated alerts for suspicious activity. 5. Disaster recovery and backup. Traditional systems require manual backup planning, while cloud systems offer automated backup and data replication. Example, weekly off-site backups versus Azure replicating data across regions. Conclusion, traditional systems offer full control, while cloud systems provide advanced, automated security. Organizations must balance control and reliance on providers to ensure effective data protection. 1. Cloud virtualization. 3 types of cloud virtualization. Virtualization refers to the creation of virtual versions of physical resources, such as servers, storage, and networks. It enables multiple virtual systems to run on a single physical infrastructure, maximizing resource utilization and flexibility. 1. Server virtualization. Server virtualization involves creating multiple virtual servers on a single physical server, allowing efficient use of computing resources. This helps reduce hardware costs and improves performance. For example, software like VMware allows multiple operating systems, such as Windows and Linux, to run on one physical server. 2. Storage virtualization. Storage virtualization combines multiple physical storage devices into a single virtual storage system, making data management more efficient and flexible. It allows organizations to manage storage centrally. For example, VMware vSAN combines storage from multiple hard drives into one virtual storage system. 3. Network virtualization. Network virtualization creates virtual networks, allowing for multiple networks to operate on a single physical network infrastructure. This improves scalability and security by isolating network traffic. For example, cloud providers offer virtual private networks, VPNs, that allow users to securely access shared network resources. In conclusion, virtualization improves efficiency, reduces costs, and increases flexibility by optimizing the use of physical resources across servers, storage, and networks. 2. 5 benefits of cloud technology. 1. Remote access, mobility. Users can access data and work from anywhere with an internet connection, improving collaboration and productivity. Example: employees using Google Drive can edit documents from home, office, or while traveling. 2. Data security, protection. Cloud providers often include secure backups and disaster recovery, protecting important business data. Example: Dropbox automatically backs up files and allows recovery of deleted documents. 3. Faster innovation speed. Cloud platforms enable rapid deployment and updates of applications, accelerating development and innovation. Example: software teams using Microsoft Azure can launch new apps quickly without worrying about server setup. Cloud technology offers businesses efficiency, flexibility, mobility, security, and speed. By leveraging cloud services, companies can reduce costs, scale resources as needed, protect data, and innovate faster, giving them a competitive advantage in today's digital world. 3. 5 disadvantages of cloud technology. 1. Dependency on internet connectivity, streaming. Cloud services require a stable internet connection. If the internet goes down, users cannot access data or applications. Example: a team using Zoom for meetings cannot connect if their internet is down. 2. Security and privacy concerns, data breach. Sensitive information stored in the cloud could be targeted by hackers, posing security risks. Example: a company storing customer credit card data could be at risk if the cloud provider experiences a breach. 3. Limited control over infrastructure, outsourcing. Users rely on the cloud provider to manage servers and infrastructure, limiting customization. Example: a business cannot directly upgrade the hardware or control server maintenance when using AWS managed services. 4. Potential downtime, outage. Cloud services may occasionally experience outages, making services temporarily unavailable. Example: Google Drive may be inaccessible during a server downtime, preventing access to important files. 5. Long-term costs, subscription. Continuous subscription fees can add up over time, especially as storage and usage increase. Example: a company using Microsoft 365 for all employees may spend significantly more over several years than investing in on-premises infrastructure. While cloud technology offers many benefits, it also has disadvantages such as dependency on the internet, security risks, limited control, possible downtime, and increasing long-term costs. Organizations should weigh these risks against the benefits to determine whether cloud adoption fits their needs. Companies producing cloud technology: 1. Amazon Web Services. 2. Microsoft Azure. 3. Google Cloud. 4. IBM Cloud. 5. Oracle Cloud. Chapter 8. Enterprise Architecture. Learn from slides 1. Based on the 4 components of enterprise architecture, explain in detail how each component works in your selected assessment domain. Enterprise architecture, EA, is a strategic framework that ensures alignment between an organization's business processes and IT infrastructure. EA bridges the gap between an organization's goals and its technology systems, playing a crucial role in digital transformation. 1. Business architecture defines the organization's business strategies, governance, and processes to achieve its goals. For example, a company may design an efficient customer service process to improve customer satisfaction. 2. Data architecture focuses on how data is structured, stored, managed, and governed across the organization. For example, a bank organizes customer data securely in databases for easy access and regulatory compliance. 3. Application architecture focuses on individual applications and how they interact with each other to support business operations. For example, an e-commerce platform integrates payment, inventory, and order management systems. 4. Technology architecture addresses the hardware, software, networks, and IT infrastructure that support applications and data. For example, a company may use cloud servers and network systems to run its business applications efficiently. 7. Complete the table. 4 types of enterprise architecture frameworks. 1. The Open Group Architecture Framework, TOGAF. 2. Zachman Framework. 3. Federal Enterprise Architecture, FEA, is mainly used in government sectors to improve coordination and standardization across agencies. For example, U.S. agencies like NASA use FEA to enhance collaboration and efficiency. 4. Gartner Framework Chapter 7 Agile IT Operations. 1. Agile in IT and importance of Agile in IT. The application of Agile principles to manage IT services, infrastructure, and development in a flexible and continuously improving way. Agile focuses on flexibility, continuous improvement, customer needs, and quick response to change. 1. Continuous improvement, regularly making small changes to enhance services and systems. Example, a telecommunication company updates its mobile app often based on customer feedback to improve user experience and add new features. 2. Automation, using technology to perform tasks automatically instead of manually. Example, an online store uses automated inventory software to reorder products when stock runs low, saving time and avoiding delays. 3. Proactive monitoring, watching for potential problems early to fix them before they happen. Example, a website hosting provider monitors server usage and resolves issues before the website crashes. Disadvantages of waterfall. 1. Difficult to make changes. 2. Late testing. 3. Not flexible for changing requirements. 4. Clients see final product only at the end. 5. Delays in feedback and delivery. 6. High risk if any stage has errors. 5. Popular Agile tools. Jira, Trello, Asana, Azure DevOps, Slack. 5 companies using Agile. Spotify, Amazon, MS, IBM, Airbnb, DOM/SCM/ITOA/Cloud/ML/Agile. 1. Improved efficiency topic is essential for modern organizations as it improves operational efficiency by automating repetitive tasks and reducing manual effort, allowing operations to run faster and more smoothly. Example, IoT sensors in manufacturing monitor equipment in real time, helping to reduce downtime. 2. Cost savings topic enables organizations to reduce operational costs by streamlining processes and minimizing manual work. It helps reduce labor costs, prevent system downtime, and avoid unnecessary expenses related to errors and maintenance. Example, a startup using Amazon Web Services, AWS, can rent server space on demand instead of buying expensive hardware. 3. Better decision-making, real-time data topic provides accurate and real-time data through monitoring systems, dashboards, or analytics tools, allowing managers to make faster and more informed decisions. Example, managers use real-time system data and reports to identify trends, monitor performance, and make decisions on system improvements or resource allocation. 4. Faster problem detection and resolution topic enables organizations to identify issues early and resolve them quickly through continuous monitoring, predictive tools, and automated alerts. Example, an online shopping system automatically detects failed payments and sends alerts to support staff, preventing revenue loss and improving customer experience. 5. Improved performance topic enhances overall system and operational performance by optimizing processes and ensuring efficient use of resources. Example, during peak shopping hours, an online store becomes slow. ITOA identifies that the server is overloaded and helps balance the traffic to improve speed. 6. Enhanced customer user experience topic improves customer and user experience by providing faster response times, reliable systems, and more efficient services. Example, online hospital appointment systems reduce patient waiting times and improve satisfaction. 7. Increased flexibility and scalability topic allows organizations to adapt quickly to changes and scale operations based on demand, responding to market changes, and handle increased workloads without major disruptions. Example, an e-commerce website can scale up server capacity during holiday sales and scale down afterward. 8. Better resource management topic ensures efficient allocation and utilization of resources such as systems, data, and workforce. This helps prevent resource wastage, improves productivity, and ensures that resources are used in the most effective way. Example: a manufacturing company implements AI and machine learning technologies to reduce waste and improve product quality, ensuring efficient and high-standard operations. 1. High implementation cost. Implementing topic requires significant investment in infrastructure, software, and skilled professionals, which can be expensive for organizations. Example: a small retail business wanting to use ML for personalized marketing may struggle with the high costs of data storage and hiring data experts. 2. System complexity. Topic manages and analyzes large volumes of data from multiple sources, which can be difficult to organize and interpret. For example, integrating logs from servers, applications, and network devices can create a complex environment that is challenging to monitor effectively. 3. Data quality and data overload issues. Topic relies heavily on accurate and large volumes of data, and poor data quality or excessive data can reduce system effectiveness. Example: large amounts of system data or alerts may overwhelm teams, causing important issues to be missed or incorrect decisions to be made. 4. Integration with existing systems. Integrating topic with legacy systems or existing technologies can be challenging and may lead to compatibility issues or incomplete functionality. Example: older systems or software may not integrate well with new technologies, preventing smooth data sharing and reducing system efficiency. 5. Resistance to change and skill gaps. Employees may resist adopting new technologies due to lack of knowledge, fear of change, or preference for existing systems. In addition, organizations may lack skilled professionals to manage and operate the new systems effectively. Example: staff may be unwilling or unable to use the new system properly, requiring additional training and slowing down implementation. 6. Security and privacy concerns. Topic involves handling sensitive data and systems, which creates risks related to data breaches, unauthorized access, and compliance issues. Example: unauthorized access to system data or user information may lead to security breaches, legal issues, and reputational damage. 7. Technical issues and system downtime. Topic may face technical problems such as system failures, bugs, or downtime, which can disrupt operations and reduce reliability. Example: system crashes or performance issues may interrupt operations and require immediate troubleshooting to restore normal functionality.